Following example, we're asked to integrate x multiplied by e to the x. This is a perfect example of integration by parts because we see the two things we're looking for. It's a product. One of the terms is an exponential function and the other is polynomial, in this case just x. So it'll fit very well into this rule, which is our integration by parts formula. So to do this, we're going to choose a u and a dv to make it fit here. So assign our integral to these two parts and then rewrite it in this form. The idea being, hopefully we get an integral here that is easier to solve than the one we currently have. So we're going to choose x for u because when we take the derivative, it becomes simpler. So choose a u so that the derivative is an easier function. In this case, the answer is 1, which is much easier than x. So we just write dx. We also need to choose dv. That's something that's easy to integrate. In this case, e to the x. Well, the integral of e to the x is e to the x. So now we're going to plug in the pieces here. So we have u times v. So this is going to equal x multiplied by e to the x minus the integral of v, which is e to the x, du, which is dx. So that's just plugging the pieces in here. Now we're left with an integral here that we can evaluate. The integral of e to the x is e to the x. We add our constant since it's indefinite integrals, and we get our final answer. This is also a good example of one that could be done with a table. If we started this question by assigning u and dv in table form, we would still choose x and e to the x. Differentiating, we get 1 and 0. Integrating, we get e to the x and e to the x. Our formula is positive then negative, so we're going to go positive, negative, positive, negative, positive, negative. We keep repeating. And we're going to multiply the diagonal terms and integrate the last term. Now we can simply write our answer. X times e to the x minus 1 times e to the x plus the integral of 0 e to the x, which is the integral of 0. The integral of 0 is a constant, so that just means plus c. And you see we get the same result. This is really good technique if you have x to some power here with an e or a trig function. Otherwise, it's good practice to use the formula as well.